This video is sponsored by PCBWay. Welcome everyone. In this video I'm going to continue my project with my DIY full-frame digital camera. So as you could see it in my previous video, I built something between a scanner and a digital camera. So I built a mechanism which moves a linear CCD, this guy here, and scans it across the frame, which is projected by this lens. And that frame happens to be at the flange focal distance of the lens. So therefore this sensor acts as the sensor or the film in a normal camera. And this is one of the PCB that I designed and built. So this one here is a TCD 1304 linear CCD. And then the PCB for it is just a holder and some signal conditioning circuit. As you can see, we have a few small parts here, which is just to condition the signal of this CCD's output. And then we have this instrument box, and I chose this because it's easy to cut it and it is large enough to hold everything which I need for this camera. And then now I have a large lens attached to it, as you can see. But what is more interesting is inside this box. And I have made some improvements, so I will show you those improvements for this camera. So now we have this mechanism. The back panel is still the same as we have. So this is just a 3D printed panel, which perfectly fits the back of this box. But then one of the new things is this holder. In the previous video, I was using a miniature linear bearing or linear rail, but then I discovered that that has too much mechanical resistance. So the motor was struggling a little bit to move it precisely and have the same step size between each steps. So now I have this kind of sliding mechanism. So we have this 3D printed block here, and that is sitting on two steel rails, and I just drilled these holes with a 4mm drill bit, and then that is sliding on this perfectly. And then these two rails on the sides just act as a support for the CCD holder, and then the CCD holder holds this triangular shaped plastic there, which is the nut for this lead screw. And this lead screw is built into this NEMA 8 stepper motor. This is a regular stepper motor, so 200 steps per turn is its, let's call it, resolution. So it acts as a normal stepper motor, it is just smaller. And then you can see that on this block, an identical CCD is sitting on the PCB. And then that moves back and forth to scan the frame projected by this lens. So one news is that I changed this mechanism to a sliding mechanism. And another, you can see it here and you can see it there, I have added limit switches. So this limit switch is the home switch. So when I turn on this device, then this mechanism goes back to this switch, switches it, and then it starts to go in the other direction until the switch is released. So that is its home position. And when I'm doing the scanning, so the CCD moves in this direction, the scanning stops when the limit switch is hit, and then the CCD immediately returns to the home position, similar way as I described when it is acting when I turn this on. So when the limit switch is hit here, the CCD goes back, hits this limit switch, and then it goes a little bit this direction to release the switch. And then it's ready to be, it's ready to run again and scan a new frame. So that's again some news. And then this stayed the same. So it's an STM32F401 microcontroller. So that drives and reads the CCD. And now I'm using an easy driver stepper motor driver because I've been using this throughout this project. I did not want to replace any of these parts. so I just kept it. And then that's about the parts on this panel. And then we have this box, and I made some news here, and that is here. I show you because I think this is a very funny improvement or build. So we have this tiny frame here, and actually I will get rid of this because I discovered that actually this is blocking part of the image, but now it's fine. But you could see that I could screw this off, and here you can also see that this has threads. So I designed this tube and this tube to fit into each other, and then I can just screw this on like this. And then you would ask, what's the purpose of this? Well, when I built this box and I used the previous mechanism, the CCD was sitting much deeper. And then instead of just designing a new part, this was the previous part like this, and the threaded metal part was sitting on top of this tube. So instead of designing a new one with a fixed length, I made this tube with a thread, or these tubes with threads, to be able to change the flange focal distance. So the distance between the end of the lens and the surface of the CCD. And why that is important is because each lens, in this case the M42 lens, has its own flange focal distance. So this distance between the end of the lens and the surface of the CCD. And if you don't manage to find that distance properly by, for example, keeping the correct distance with your 3D printed part, then you will have some problems when you are trying to get a focused and sharp image, because then either you focus the image behind your CCD or in front of your CCD, and that will not result in a good image. So then I can turn this and fine-tune my flange focal distance, and then I can use this lens properly. So that's the, let's say, advantage of this thing. And once I settle everything with the, let's say, development, then I will make a final part where I manually measure these things and I print a fixed size holder for the lens. But until that, I will use this 3D printed part to have some flexibility in adjusting the flange focal distance. So then you can see that I use a lot of 3D printed parts. For example, this extension, the back panel here, which will be replaced by a PCB in the future. And then of course the wall mechanism is basically 3D printed. And then I also use a custom made and custom designed by me PCB for this TCD 1304 linear CCD. So then this is a good and relevant moment to introduce today's video's sponsor, PCBWay. So if you want to print, for example, similar things that I printed here, or, which is more important and more fun, get this PCB, obviously without this component, but get this PCB so you can make your own PCB for this linear CCD. You should head over to PCBWay.com and check my project website, because I shared this specific PCB and also many of my other PCBs. And you can order it from PCBWay, and they can manufacture it for you, so you can build similar projects. And also, if you are interested in 3D printing, go to their 3D printing related webpage, and then you can upload your designs and order it from their services. So coming back to this PCB, you could see my improvements, so the mechanism and this adjustable tube. But I think what is more important is that I should present you the capabilities of this thing, because there is a third stuff which I improved. It is the software which captures the data on the computer and then makes it into a visible image. So let's head over to my computer and let me show you what I made with my software. So we are here at my computer and I have already opened the software, but I haven't connected anything. And this display can be familiar to you if you've been following my channel, because this is the same software that I use for my spectrometer, for example. But now I have added another option to this, and that is the so-called imaging mode. So then I start that mode. So now we have a black frame here. And then the scanned image will show up here, basically column by column. So as the CCD scans the frame, then from left to right we will have the image showing up basically in real time. So then I just connect to the microcontroller. We are connected, and then I select a large integration time because we will need quite a lot of time for one frame, or to be more precise, to one column of the whole frame. So let's say roughly 5 milliseconds. And now, before clicking on the start, as I start, this will be slow. So in the beginning I will talk a little bit, and then I will just speed up the video, because to scan one full frame it will take like 3-4 minutes. So I just start this, and you will probably hear the noise of it, and you will see the picture as well. So here you can see as it is progressing, so you see the different shade. And now here you can start to see something showing up. I just put together a few things on top of my night stand next to my bed. So this will be looking at some objects. And here you can already see some stuff, and even more. So you can see that the image doesn't have very strong contrast, and it's not super sharp, but you can start to see the objects, and I think they are more or less well visible. So you can recognize this lamp here, and then probably you can recognize this cup and this logo in front of it. And if you like electronics, you probably know this book as well. And now let the frame finish, and then I continue talking. So now the frame is finished, and we have 3,454 columns here, so it's quite a large resolution image. And in the background you can probably hear that the motor is going back to its home position now. So essentially the CCD is returning to this side of the frame. And I saved this image with this button here. And then we can look at that image. So here is the image, and you can immediately spot that the edges are not perfect, and this is because of the thing that I mentioned previously, that I should get rid of that frame inside the lens tube, because that is blocking some light. So yeah, this is the proof of that. And then let us see what's the resolution of this image. So yeah, here you can see the image parameters. So it's 3,500 pixels on the x-axis and 3,694. I tried to make the scanning and the step size in a way that I know that I have a fixed amount of pixels on the y-axis, and I try to adjust the number of pixels on the x-axis, so I get a 3:2 aspect ratio. So actually I could stretch this image a bit to make it look a bit more decent. But yeah, so you can see that this is a very large resolution image, at least very large as compared to a homemade digital camera. So that's nice. And then if we return to the image, we can zoom into this and just try to reveal some details. So yeah, you can see that the image is not perfect. It's not perfectly focused, but we can see the shapes quite nicely. You can read the text, PCBWay here. You can see that this is a cup. And I put a lens here, and these are supposed to be the numbers on the lens, but you can obviously see that you cannot see it. And then again, lack of focus here, or I did not nail the flange focal distance perfectly, but I can read this, troubleshooting analog, and then yeah, these are supposed to be circuits, but of course if you don't know what is written here from previous times, you would not know how to decipher this mess, but this is circuits. And then here, this is my spectrometer with my PCB. The same PCB is on the back of this thing, which is operating in the camera, and I have the same microcontroller here, so that is quite nicely recognizable. Then this is just a decoration from Jysk, and here we have a book, and you can see here that there is a small bump in the book, and that's not a dent on the book, but I probably bumped into the table while it was scanning, so I caused this small jump. But at least this part is readable, so that's nice. But you can see that there is a lack of focus, so I could play with this for hours to get a good focus, but if I like zoom out, then I mean on Instagram or something, no one notices what is going on. And actually this side of the picture, the right side, is not weird up until like you see this, because here I have the corner of the wall, so this is just going out from the plane of this wall, opening to another corridor, so this is just a wall at a weird angle. So yeah, but you can see that if we go even down to like pixel level, it's quite okay, I would say. But of course I have to work on the focus. So probably the next part will be to work on the focus a bit better and make it possible to get good focus without doing this trial and error, because I had to scan a few frames to be able to get this good focus at least. But then obviously it would be nicer if I could get the focus without trial and error. And then with that I could also try another thing, is to try to get the exposure time. Because here in the software I can have the different integration times right here, and they are like pre-programmed, but I have to guess what kind of integration time I want to use. So of course this is also a bit trial and error. And then as I said, I will add some buttons to this box. It will have a display as well and an SD card, so these images can be saved on the SD card or the matrices for the images, and then I can convert them on my computer. So that is the future. And of course the back panel, instead of the 3D printed back panel, will be a PCB, so I can connect everything together, like the microcontroller, the stepper motor driver, the SD card port, the display, and all these things. And also I could have it not only as a circuit board but also as a structural element, because this would be the back side of the wall enclosure basically. But yeah, now you can see that I can scan relatively okay images with this thing, and I solved, let's say, most of the hurdles with the mechanism. So the next part is really to make it work with a display and SD card reader. So I hope that you found this status update interesting and useful. If you have any questions, please let me know in the comment section. Don't forget to visit pcbway.com, and also don't forget to visit my website, because I put up some extra pictures and I wrote an article about these updates and everything. So it might be something interesting for you. And I also have a Patreon, so if you want to have some extra stuff or you want to just support me for my efforts, then please feel free to join my Patreon supporters. I hope you like this video, I hope you learned something, and see you in the next video.